Now let us understand what exactly is this dummy variable as we discussed in the previous session. Now let us understand about some feature. That feature cannot be represented in a numeric value. For an example, there is a color or there is a portfolio. This cannot be represented in a numeric value. For an example, color. Color could be red or green or yellow. And the portfolio is such as clerk or manager or something else. This cannot be represented as a numeric values, right? When these are not represented in numeric values, we know what is the problem in our data set. Data set, the feature, if it is only in the numerical, then the model will be able to take it as an input, right? So the thing is, here we are going to introduce the dummy variable. Dummy variable meaning we are going to transform our categorical variable into the numeric values. Okay, this is very similar to one-hot encoding, but there is a difference in between one-hot encoding and dummy variable, which we are going to discuss down the line in the session. Now, in the statistical and machine learning, dummy variables are the artificial variables created to represent the categories in the categorical data as numbers. For example, color. Green will be encoded, red will be encoded, and also black will also be encoded. But each of this variable will create a separate column. If the color is green, in the green will have a column, and if an attribute, if an entity has a green color, for that entity against the green column, against the green feature, it will be equal to 1. I am going to show you. Why use dummy variable? Many statistical models cannot handle non-numeric data directly. Many statistical models, it cannot handle the non-numeric data. For example, if you have a categorical variable such as color with the variables red, blue and green, you cannot input these directly to the most models. Of course, some models are exceptions, but most of the models cannot take this non-numeric values. So dummy variables provide a way to encode this categorical into numeric form. How the dummy variable work? For each category, there is a separate column. For each category, there is a separate column. There is an example for each observation, 1 indicates the represent of the category and 0 indicates in its absence. For an example, there is an entity. Okay, first entity is a green color. Second entity 1 is green color. Entity 2 is of red color. So what I'll do is, for green and red, I'm going to create 2 different columns. So for the entity 1, against the green, I'm going to have 1. And for against red, I will have 0. For entity 2, against red, I will have 1. Against green, I will have 0. Our dummy variable representation, for red, it will be 1, 0, 0. For blue, 0, 1, 0. Green is 0, 0, 1. What is the dummy variable trap here? Now, sometimes what will happen in a data set, all the variables will be categorical variables. There are no numerical variables at all. No variables will have the numerical values. All the variables are categorical variables. So what may happen? As you predict right, there will be a problem of multicollinearity here. Okay, so that is what a dummy variable trap. The dummy variable trap occurs when all categories are included as the dummy variables in the regression model. Okay, the model, there is a data set. Every feature is a categorical feature. There will never be a numeric data. So every feature has to be converted into a dummy variable, right? So this will lead to multicollinearity problem, right? So what is the solution for this? To avoid a dummy variable trap, always drop one category. Whatever the variable that is not contributing, rather that you feel that it is insufficient or it is ineffective, you can drop that one. For an example, there is a color example. If we drop the green column, we'll get red, blue. We'll only get red, blue. Here, green is highly multicollineating with red and blue. So we can drop green. So we'll have only red, blue and green. Sorry, red, blue, green has actually been dropped. Now, both red and blue are zeros. We know this observation belongs to the green category. That means, for an example, when both red and blue are equal to 0, for an example, entity 1. Entity 1 belongs to, let us say, the green color. Now for entity 1, red will be equal to 0, blue will also be equal to 0. Obviously that entity belongs to the green color, right? Okay, so that's how we'll be able to solve the problem. Advantages of the dummy variable: model compatibility. The model will be compatible for any model, either for classification or regression. They allow the categorical data to be used in the statistical and machine learning models. Flexibility encodes the multiple categories for the better model interpretation. Obviously, as we understood for several times, the numerical values are the good fit and input to the models, the categorical models, or machine learning models, what do you call? The interpretability, obviously model interpretation, the predictability will always increase with the dummy variables. Okay, take a real world example, dummy variable in a regression model. So I'm going to take a regression model here. Dummy variable representation is manager 1 and engineer. So let us say there is a manager, there is an engineer, there is also something called a clerk. Okay, here what I'll do is I'm going to drop the clerk. For an entity, for a person, for a respective person, or for an employee ID against to the employee ID, if manager is equal to 0 and engineer also is equal to 0, obviously that person, that employee ID will get mapped to the clerk, right? Okay, this is how it just works. This regression equation becomes salary is equal to intercept plus coefficient into manager, coefficient 2 into engineer. This is the regression equation. Here, intercept is the salary for the reference category clerk. Coefficient and coefficient 2 is to represent the effect of being a manager and an engineer. This will be your, the regression equation. Okay, now, since this is very similar to the one-hot encoding, there may be a doubt that what is the exact difference in between one-hot encoding and the dummy variable. Although both are very similar, in one-hot encoding we are not going to drop any variables. We are not going to drop, that is not going to handle your multicollinearity. In multicollinearity, we are going to create a dummy variable to avoid the multicollinearity, right? So, that is the reference. Reference is aspect of dropping a category, dummy variable drops one category to avoid redundancy, and in one-hot encoding we are going to keep all categories, creating one column for the category. Use cases used in the regression models to prevent multicollinearity. In one-hot encoding, common in machine learning models where multicollinearity is not a concern. In machine learning models, multicollinearity is not a concern, but in regression models, as we already knew, multicollinearity is a concern. But in machine learning model, we are going to use one-hot encoding. And the interpretation, each coefficient represents the effect of the category relative to the reference category. And here, no reference category at all is needed. All categories are treated independently because there is no reference category. Here, we are going to have a reference category for each coefficient. But there, in a one-hot encoding, no reference category. We already discussed about one-hot encoding. I want you people to go through the one-hot encoding in which there is no reference category at all. All those categories are treated independently. That's the very reason why we wouldn't get to this multicollinear problem, right? So, that is with a dummy variable and one-hot encoding. Thank you so much.